Yes, the construction technologies. Myself, Dr. Y. Sreeramulu, Professor and Head of the Department of Civil Engineering. I had 20 years of professional experience. For the past 5 years onwards, I am working with Annamacahrya Institute of Technology and Sciences, Rajampeta. My previous organizations are the initial one is the Tata Consulting Engineers. Myself work with RUID project, that is Rajasthan Urban Infrastructure Development Project, whereas the designs and construction of water supply lines as well as sewer lines, including the treatment plants also, myself involved. Afterwards, I worked with the Panchayat Raj Department, Rural Water Supply and Scheme for Kurnool district in the SC office. And I had worked also with reputed organizations like Engineering Staff College of India, CBIT Hyderabad, KL University. Yeah, you can come to the today's presentation on new trends in construction planning as well as technologies. My presentation is focusing on completely the technologies involved in construction, in the existing as well as future technologies. The construction, as we know the definition, it is the process of making something, the occupation of building or the way the something is put together. Majorly, the civil construction includes in the category of civil engineering, which is all about designing, constructing, and maintaining the physical and naturally built environment. Construction is the art of building bridges, dams, roads, airports, canals, as well as the buildings. The civil construction is three types of sectors, which includes buildings, infrastructure, industrial structures. Again, the buildings are subclassified residential and non-residential constructions. It also subclassified as residential buildings, light commercial construction, multi-family construction, that is apartment culture, healthcare construction, environmental constructions, industrial constructions, institutional construction, infrastructure project constructions, including roads, bridges, canals, highways. The construction technology basically defined as construction technology involves study on methods of construction to successfully achieve the engineering design with recommended specifications. It also includes study of construction equipments and temporary works required to facilitate the construction process. See the history of construction technology. The Neolithic construction stage, that is New Stone Age, which is roughly from 9000 BC to 5000 BC, that is before Christ. The tools available were made from natural materials including bones, stones, wood, animal fibers, and the use of water. The first building were shelters, tents, and huts. It's built self-sufficiently using locally available materials, which has happened in the Stone Age, that is Neolithic construction. Next stage is on Copper Age and Bronze Age. which came into use before 5000 BC, and bronze around 3100 BC. Although the times vary by region, copper and bronze were used for the same types of tools as stones such as axes, chisels, but the new, less brittle, more durable materials. Next stage is Iron Age construction, which is during 1200 BC to 50 BC, with the widespread use of iron for tools and weapons. In this period, where by adding carbon, iron become steel, which was being produced after 300 BC. Steel can be hardened and tempered, producing a sharp, durable, cutting-edge technologies. Next, the Middle Age, which is from 5 to 15th century AD, that is after death of the Christ. From the fall of the Western Roman Empire to the Renaissance, iron ring beams are used in most buildings in Northern Europe, were constructed of timber units until 1000 AD. The brick continued to manufactured in Italy throughout the period of 600 AD to 1000. The Renaissance stage, the Renaissance started in the Italy. The inventions of movable type and the reformations are taken. In the 17th century, that is the birth of modern science it calls. However, it was not until the 18th century that engineering theory developed sufficiently. Up to that, it is not professionally developed. In the 18th century, it saw the development of many. The ideas had been born. The architect and engineer became increasingly professionalized. Whereas in 19th century, the industrial revolution took place. The industrial revolution was manifested in new kinds of transportation installations such as railways, canals, and macadam roads. In the 20th century, elevators and cranes made high-rise buildings and skyscrapers possible. Other new technologies were prefabricated and computer-aided design. Whereas the end of 20th century, ecology, energy conservation of sustainable development have become more important issues of construction. And coming to the 21st century, took place smart materials, and we are going to see the futuristic technologies. The perspective on our construction industry in 21st century, how are we doing, where are we? We are not up to the mark because of when the project is sanctioned within a duration of 1 year, but we are unable to complete within 1 year. It is taking more than 1 year. It may go to 2 years or 3 years. There is a loss on the investor side as well as contractor. The cost will be day by day increasing. So to arrest all these things, we have to see the alternatives, that is alternative technologies and emerging technologies. And also you see the problems in industry. Future state of our industry is how much we change to get there, and role of innovation and new technology. Why the construction is very important? As all of you know, it is one of the business developed. Virtually all other businesses rely on construction. The people spend 90% of their time in indoors. Major impacts on health and well-being. The total annual revenue is from the $10 trillion, whereas added value is $3.6 trillion. Here, the employees, over 100 million people are working in the construction sector. It's almost largest global consumer of resources and raw material. It comes almost 6% of global GDP. The populations of urban areas are increasing by 2 lakhs people per day. So we'll need housing as well as the infrastructure to accommodate for this population. Our industry must transform, but our country is challenged. There are challenges in the industry as well as in the country. To overcome that, we have to see these new technologies. You can also see the future construction. There is the market and customers need. There is the problem of aging infrastructure. There is a problem of sustainability and resilience. We have to strive for it. We have to go for society and workforce, politics and regulations. We have to see day by day these are changing. Here, the shaping the future of construction. Our infrastructure is aging, that is old. Shaping the future of construction, the projects are bigger and more complex. You can see the global competitive index. The first one is Switzerland, then Singapore, US, the other countries. So in the 138 countries, India is not having a place, whereas Canada is having the place of 15th. How does Canada compare? We will take a case study. It is having the basic requirements, which includes infrastructure, macroeconomic environment, health, primary education, whereas the key for factor-driven is economics as well as efficient and enhances sub-index, higher education, good market efficiency, labor market, financial, technology, redirections. The key for this is efficiency-driven economics. It's also the innovations and sophistication factors. These put the Canada, which in the 15th place. You can see how Canada made very good efforts than India. Canada drops slightly by 2 places to 15th since 2007. The most contributions to Canada competitiveness score have come from improvements in technological readiness, health, primary education, and labor market efficiency. On the other hand, this year sees a continuing downward trend in innovation, business sophistication, financial market development, infrastructure, and good market efficiency. Canada ranks among the top 10 countries in health and primary education, labor market efficiency, and financial market. The construction performance also has performed poorly when compared to other industries. There are internal challenges. The industry must also confront internal challenges, which are lack of innovation and delayed adoption, informal process or insufficient rigor, and consistency in process execution. Insufficient knowledge transfer from project to project, weak project monitoring, little cross-functional cooperation, little collaboration with suppliers, conservative company culture, and shortage of young talent and people development. So the construction environment includes unique construction environment. The knowledge should be transferred from project to project. How can we transfer our industry? The transformation framework can be including technological materials and tools, which is advanced building and finishing materials, smart materials, life cycle assessment should be increased. The strategy and business model innovation, industry collaboration, process and operation, people organization and culture, joint industry marketing. It also transformation framework will be taken place through regulation and policies which are harmonized building codes or standards and efficient permit process. Market openness to international firms and SMEs. Promotion and funding of R&D, technology adoption and education. It also includes public procurement. It is actively managed and staged project pipelines with reliable funding, strict implementation of transparency and anti-compulsion standards, innovation-friendly whole life cycle procurements. So it also includes the technology, material and tools, strategy and business model, process and operations, people, organization, culture. The industry collaboration includes the sector level, which is mutual consent on standard across the industry, more data exchange, benchmarking and best practical sharing, cross-industry collaboration along the value chain. Joint industry making consists of industry-wide collaboration on employment marketing, coordination, communication with civil society, effective interaction with the public sector. How we can technologies are implemented? The act of building is a basic component of human activity. For centuries, humans have created structures, beginning with the simplest of huts to the most modern of skyscrapers. All along the way, construction technologies and practices are advanced. The civil engineering has always readily adopted new technologies using innovations like suspension systems to build bridges and GPS to plot new roads. And as technology continues to evolve, we can expect that the civil engineering field will only incorporating this new technology in increasingly creative ways. New technology makes work easier, faster, and reduce the cost. The scope of these new technologies are these techniques are sustainable, wide range of applications, consumes very less time, durable. All these techniques involves use of alternative energy source which is renewable, eases the construction work, and there is lot of scope for future. These techniques also use recycled materials to create new things. These techniques can be used in place where human cannot access, like dangerous places which is hazard without man supervision. The technologies which are the drones, which is UAVs, that is unmanned vehicles. These unmanned aerial vehicles, the civil engineering is right with application for unmanned aerial vehicles which can aid in scanning, mapping work sites as well as capturing photos and videos for promotional purpose. So this will create advanced mapping and scanning capacities for more accurate visualization. The UAVs are often represent a cost-saving measures for business that need aerial mapping, as a drone does not require any pilot, but rather a programmer. UAVs are also easy to program to fly multiple times around the same work site, which means in the future, firms will be able to capture a variety of images and videos while the project is being completed, and that will enable firms to better manage project progress. These UAVs will also revolutionize civil engineering through the use of photo scanning, an image capture process that uses photos rather than lasers to capture images. Photo scanning captures not just the ground surface, but also buildings, plants, branches or benches, and other nearly structures, and represents them in the three-dimensional mode. With these advanced capabilities, drones will allow for more accurate and more interactive 3D representation of civil engineering projects. Even the trends of drones and robots, the UAV industry continues to grow. The FAA, which is drones prediction, which is taken by Federal Aviation and Administration, the USA organization, which predicts that 7 million drones are required by 2020, which are there for commercial applications for construction, in earthworks management, location validation, project management, etc. Even new collaborations are also taking place. The rise of robotics, the Virginia Technology and Lois Robotics, the non-monitorized exoskeleton address common lifting injuries. The harness features carbon fiber rods to act as artificial tendons, so which can be used for this purpose. Few more trends in augmented and virtual reality. It's need to clarify the difference. The virtual reality is, which is the immersive experience, whereas the augmented reality is information overlaid onto real-time visuals. So these smart elements, smart glasses, etc., which are manufactured by the DAQRI industry, which is an American augmented reality company for the safety of the workers in the construction sector. So this DAQRI smart helmet, which is taken testing, similarly glasses which can visualize the virtual reality and augmented reality by the employees. The trends augmented and virtual reality, the DAQRI smart helmet, which is Microsoft HoloLens also, for the safety of the worker and which can visualize. The sensors also will be the emerging technology where the health and safety of the workers which are taking place, Liveband sends a signal through a mobile application if signs of mental fatigue are shown. It's measuring brain activity. Means when the person is working, if any problem or any fatigue occurs, immediately it will give alarm through the sensors. The large scale testing also, the Washington University study on large scale infrastructure projects where the sensor are took place. You can see in this picture. There the sensors are fixed over the wireless environmental sensors deployed across projects, the tracking ambient quality, this the temperature, humidity, noise, vibration, etc., which can be also the safety sensors, which are tracks technologies unveiling its belt mounted sensor to log workers' movement. Accelerometer and gyroscopes details suddenly falls on movement. So now you can see here this is the technology which is shown here, the Microsoft Building 2017, where the sensor is taken place, where the sensor is taken place. Here it is took place where the fatigue happened or any problem happened in the workplace, then immediately it will give the alarm or as well as give the response to the people, whereas it should be reached to the managers. The robot swarm construction you can also see here. The termites can build large structures despite having no central supervision. Getting inspiration from these researchers at Harvard University developed by following an initial design. The four-wheeled robots can build brick-like walls by lifting each brick and laying them in required position, and they have sensors to sense other robots so that they won't collide with each other. This technology can be used in building space stations on Mars planet and in construction of deep underwater gas pipelines. This technology is being experimented in building undulating brick towers also. The one more technology is carbon nanotubes. A nanometer is 1 billion of meter. Using cutting edge techniques like electron beam spectrographic, engineers are created tubes of carbon with wall 1 nanometer thick. They have highest strength to weight ratio of any material on earth and can be stretched to million times longer than their thickness. They are very light and strong, so can be embedded into other building materials like metals, concrete, wood, and glass. It increases tensile strength also. A lot of research work is going on in monitoring stresses inside building materials and identifying potential fractures and cracks before they occur. The innovative of construction material, which is self-healing concrete. Concrete is most widely used material on earth, that is second most used after water. But it is subjected to cracking, stresses, deterioration under extreme hail and cold conditions. The only way to fix concrete was to patch it or reinforce it. But in 2010, a graduate student and professor at Rhode Island created a new type of smart concrete that heals its own cracks. The concrete mixes embedded with tiny capsules of sodium silicate. When the crack forms, the capsules rupture and release the gel-like healing agent that hardens to filling the voids. Other researchers have used bacteria or embed glass capillaries or polymer microcapsules to achieve similar results. This concrete not only makes structure safe, but also cut down greenhouse gases and make it sustainable, which is one of the innovative material in the construction. Next is on permeable roads. The permeable pavement, also known as pervious or porous concrete, is a specific type of pavement with a high porosity that allows rainwater to pass through it into the ground below. Through this movement, pervious concrete mimics the natural process that occurs on the ground surface, consequently reducing runoff and returning water to underground aquifer. This is eco-friendly roads. It also traps suspended solids and pollutants, keeping them from polluting the water stream. The pervious concrete has many applications, most commonly the low volume pavements, residential roads and driveways, sidewalks, parking lots, low water bridges, well linings, swimming pool decks, etc. The concept was proposed in the 1960s in hopes of reducing floods, raising water tables, and replenishing aquifers, while a decade later, the Environmental Protection Agency began testing it to determine its cost and efficiency. So with these permeable roads, there is a huge saving of water in the groundwater aquifers. The water and aggregate are added in specific amounts to attain pervious concrete with a high air content and just enough cementitious paste to coat particles and interconnect. The low cement and high air content results in reduced strength, hindering pervious concrete from being used on highways, certain streets, or heavy loading areas. You can see in the figure, the permeable paving can be one part of building, green parking, which can also include rain gardens or trees, solar covers, and other creative elements. One more technology is aerogel. The aerogel is a synthetic porous ultralight material derived from a gel in which the liquid component of the gel has been replaced with a gas. It is 90% of air. The aerogel is a solid with the lowest known density. It stands up to 2000 times greater load than its own weight. It has extremely low thermal conductivity. The material is very suitable to limit the heat losses of buildings. Its melting temperature is 1200 degrees centigrade, well dampens vibration and sound. Aerosol is the only compound with significant thermal insulation capabilities. It is the least dense material on the earth, a foam-like material which held its shape despite being almost light as air. Due to their transient nature, they are nicknamed as frozen smoke. The certain foam, that is the ceramic foam structure, is the world's best thermal insulator, as it is almost cancels out the three methods of heat transfer, that is convection, conduction and radiation. Here the NASA used an aerosol to trap space dust particles aboard the Stardust spacecraft. The particles vaporize on impact with solids and pass through the gases, but can be trapped in aerosols. NASA also used aerosol for the thermal insulation of the Mars rover and space suits. Aerosol concrete is also available, which is made from aerosol granular gypsum cement and can be used for foundry applications, structural panels. This is also one of the best products which can be used in modern construction. The advancement in this 21st century is the 3D printing. The 3D printing, which is actually the 3D printing means the action or process of making a physical object from a three-dimensional digital model, typically by laying down many thin layers of a material in succession, which is a 3D printers which take data from a computer generated model and translate that into a real solid form. The 3D printing is gaining a lot of ground, not just among hobby, but also business. And with 3D printers coming down in price each year, it is not long before we will see them used as a civil engineer. 3D printing offers benefits for both design and construction, essentially tying the two processes together with 3D printing. It is easy to design custom construction supplies and then build them using nearby any kind of material imaginable. In fact, 3D printers are already in use in construction projects in Europe. Dutch construction company Ismans, most well known for its smart highway and its glowing bicycle paths, which use luminescent paint to clearly mark road lanes at night. It has created the world's first 3D printed bridges in collaboration with startup Mix 3D and designer Joris Lamont. The bridge, which was first designed in October 2015, will span across the Leipzig Architectural Canal and it's completed in 2017. The Mix 3D model, MX3D's 3D printer is not like those that we have traditionally seen. Rather than a desktop 3D printer, the MX3D's technology consists of a set of large mechanical arms that hold a torch-like tool for welding. This robot arm build 3D objects in an open warehouse space rather than the inside box as most 3D printers do. The arms can also print in all directions, unlike typical 3D printers, which allows for much more creativity and variability in the design stage. The Hispan's innovation manager say that 3D printing joins design and construction into a single process rather than two separate processes, as has traditionally been seen in construction. Vander Van notes that this change will require site managers and designers to start looking at the design process in a new way, which can speed up the construction. The one more construction technologies includes plastic roads, improving the durability and lifespan of our roads. The plastic is one of the most commonly recycled products, with plastic materials often being recycled into bottles, bags, toys, containers, and much more. But now, a Dutch company is attempting to recycle plastic into something much larger, which includes roads. Walker Vessels is a Dutch construction firm that is preparing to build a plastic road in Rotterdam. While Walkwar Vessels plastic roads is still only a concept, it is becoming quite popular in Holland, where 96 million tons of carbon dioxide are released into the air through road building and maintenance alone. Walker Vessel expects that its plastic road will reduce greenhouse gas emissions while making roads stronger and increasing their lifespan. The plastic road also allows for easy infrastructure upgrades as the road is hollow, which enables city planners to run pipes and wires inside the road itself. Civil engineers say the road's hollow cavities may also be useful in draining flood water in the event of rainstorms. So these plastic roads also will solve the problem of this lifespan of the roads as well as plastic pollution. Next revolution is the holographic computers. The next revolution in the wearable technology is here, and it's going to forever change information management and communication process in the civil engineering industry. HoloLens is a mixed reality set that layers 3D hologram over physical world images in order to convey helpful information to the wearer. Using the HoloLens, civil engineers can see digital input drawn over physical objects, share that input with collaborators, Skype, fine-tune designs in 3D, and explore designs in real time. Currently, business in the architecture and construction industries are piloting the HoloLens and developing innovative new process that leverage 3D holographic models to improve the design phase. So here the contactless security cards, which is improving on RFID to boost security for the workers. Site security is always a primary as well as priority, and with technology evolving, site managers need more and more security measures at their disposal. The next big thing that is in site security is contactless security cards. These cards can be programmed with individual profile information to uniquely identify each card holder and can give users to security, access to secure officers, secure parking, and even computer networks. The great advantage that these smart cards offer is that security becomes much easier to manage. Employees can check themselves into and out of the work site with just a swipe of a card, and manage have a turnkey security solution that does not require their consent presence. The only disadvantage is cards are mostly likely to be lost or stolen, and there is possible of hacking. The road printer, which is paved roads, are suitable for communities because they are easy to maintain and repair. The road paving is a slow process, but this machine, that is road printer, speed up by multiple times. So directly you can save the time and money by using these road printers. The solar paint, one of the technology here, the solar panels are big and chunky, yet they are not that powerful. Companies are developing spray on solar cells using nanoparticles of zinc and phosphorus. The solar paint, also known as paint on solar or paintable solar, works the same as any other photovoltaic cell by collecting the energy from the sunlight and converting it to electricity. So these are the main thing. Now roads are becoming the sources of power generation. The basic idea is that billions of tiny pieces of light sensitive material are suspended in a flexible liquid like a ink or paint, which can be sprayed onto various shapes and sizes. In 2014, the researchers at the University of Toronto experimented with solar paint made of tiny dots known as colloidal quantum dots. For the building's point of view, the technology which is derived in the 21st century, that is the BIM model, that is building information modeling, which is a 3D model. The building information modeling is an intelligent 3D model based on process that gives architecture, engineering, and construction, that the AEC professionals the insight and tools to more efficiently plan, design, construct, and manage building and infrastructure. The benefits of this building information modeling is it is a pre-construction project visualization. You can see at every point the 3D view, you can see the construction of project. The model-based cost estimation, which includes cost estimation in the design itself. There is no need of taking two separate methods, that is designing. There is no you are going to for StatPro and for estimation you are going to Primavera. There is no need use of two softwares. It's a combination you can use by this model. It is an integrated model for both design and cost estimation. It is improved coordination and visualization in design. High level of customization and flexibility is there. easy maintenance of building life cycle also, better project quality. So all these key features are there in BIM modeling. The advantage of all these technologies are most of these technologies are sustainable, very less carbon emissions. All these technologies use alternative energy sources which are mostly renewable. These technologies eases the construction works very fast and long lasting. RoboSwarm technology can be used in places where access for manpower is difficult. Smart concrete, that is self-healing and permeable concrete, reduces waterlogging problem, runoff problems, and problem of repairs. The aerogel, which is energy efficient, wonderful material, which can be future construction building material. The drones had made surveying very easier, wider, faster. The plastic road uses recycled plastic, which solves problem of disposing. A few disadvantages are there with these technologies that should be overcome through advanced research. As these technologies are new and not widely used, the cost is also high. These technologies requires skilled labor to implement them. The primary disadvantage for drone use in civil engineering is the initial and capital expense required to purchase drones and train pilots, that is programmers. However, the cost is expected to be declined over time. The 3D printers are limited in the kinds of materials they can print. 3D printers also pose a threat to manufacturing jobs, and training staff to use 3D printers may require a significant capital investment. Recently, with these 3D printers, not only by using of cement and additives like polycarbonate, even concrete also using, so it overcome the problem of material, but regarding the manufacturing jobs and training to staff is required. The roads components are also somewhat volatile, and exposure to chlorine will cause the road to give off hydrogen chloride, a colorless gas that, when exposed to atmospheric humidity, turns into hydrochloric acid. When it becomes sufficiently concentrated, hydrochloric acid forms an acidic mist that can cause irreversible damage to human tissue. HoloLens does come with certain disadvantages. The headset could serve as a workplace distraction that hinders productivity. Here are a few more innovations which are there. That is, walls innovations in construction. Walls first sideways, that is moving elevators unveiled in Germany. Exoskeleton suits promise lower fatigue, higher production by construction works. World's first 3D printer bridge officially opens in Las Vegas in US. France officially unveils world's first solar panel road. Self-driving track loader diverts on construction sites. 3D concrete printers that can print structures in less than a day. That's what we discussed. The Tesla solar roof shingles with 8 green building products to have the green concept, which is also one of the revolution in the 21st century. All is going for green. The researchers discover an additive to help concrete to withstand the magnitude of 9.0 earthquake also. The Microsoft targeting construction trades with new mixed reality hard hat accessory for the worker safety. World's first 3D printed excavator is taken place in the Germany. America's first full-scale heated concrete slab also at an airport. Washington DC contractors add RFID tags to workers' hard hats to track whereabouts. Colorado dot test world's first self-driving construction vehicles. In the work site, this will be the vehicles are traveling without worker. It is a self-driving without collide. The construction applications integrating with each other. New hard hat attachment sensors when workers are fatigued. Finally, the Massachusetts Institute of Technology researchers design a material which is 10 times the strength of steel by changing the geometrical configuration from two dimension to three dimension, which the professors made a research that is Marx Bachelor, Jaukin, Gang Saab, Jung. So these are the few innovations in the construction sector. There is large implementation worldwide in the construction sector so that the construction sector will blooms automatically the construction the countries growth also will be taken place which will flourish the human beings lives. This is what I want to share with you, all of you. Thank you for your patience listening. If you have any queries, you can ask